should have gotten the handout from the substitute. It has two sides. They look pretty similar. However, one side says homework on the top. So just make sure, or it says handout, operations with whole numbers, fractions, and mixed numbers. Okay? So you're not on the side that says handouts. You should be on the side that says perfecting our skills, just like you see the title right up here that I'm looking at. Okay, so the first thing we're going to go through is we're going to look at multiplying a whole number to a fraction. Okay? So what we need to remember is that a whole number can be expressed as a fraction. Okay? It's basically like it has a 1 underneath it. Because remember, a fraction says 12 out of 1. That would be like 12 wholes, okay? Each thing cut into one piece. So we can go through and basically, if you're having to deal with fractions, you can turn any whole numbers into a fraction by putting a 1 in the denominator. And then we're going to use our same fraction operations. Oops, sorry. So we're going to have 1/3 times 12 over 1. And remember, with multiplication, we multiply straight across. So here we get 12 over 3. And that reduces. 12 goes into 3 evenly, so we can actually do 12 divided by 3 and just get 4. Okay? For problem number 2, we're doing 4 over 1 times 1/2. So again, we multiply the numerators. That gives us 4. We multiply the denominators. That gets us 2. And you either recognize that 2 can divide evenly into 4, or if you started to reduce the fraction like this, you would get 2 over 1. But again, you should recognize that that's just the number 2. For number 3, we have 3/4 times 8 over 1, which is going to give us 24 over 4. So again, I recognize the fraction bar as division, and I know that 24 divided by 4 is 6. Or I start reducing the fraction, and when I reduce, it reduces to be 6 over 1, which is just 6. And our last problem here is 5 over 1 times 2/3, which is going to give us 10/3. Notice that this does not simplify completely, and there's not even a factor that goes into both 10 and 3, so I'm going to leave the improper fraction as my answer. Okay? So when we're multiplying whole number to a fraction, we can make the whole number a fraction by putting a 1 in the denominator and then treat it as we normally would with our fraction operations. If you need to ask the sub to pause the video to copy anything down, ask them and then finish copying what you need to copy before we move to the next slide. All right, so the next thing I want you guys to do is summarize the process of multiplying a whole number to a fraction. So we said that first we would write the whole number as a fraction. So remember, that involves taking the number we already had and putting it over 1. Okay. The second step we would do is we would multiply following the normal rules. And then for our answer, we simplified if possible. All right. Again, if you need the sub to pause the video, ask them politely to pause the video while you finish writing down whatever you need, and then they can play again when you're ready to move on. So the next thing we're going to do is we're going to add and subtract with mixed numbers. Okay? So just a small reminder that to turn a mixed number into a fraction, okay, say I had 4 2/5. Remember that in order to turn this into a fraction, we multiply the 4 times the 5, and then we add 2 to it. So that's going to give us 4 times 5 is 20, plus 2 would be 22, and you keep the denominator. Okay. And if you took 22 and divided it by 5 right now to get a mixed number, you would get back 4 2/5. So we're going to use this as we're going through each of the problems. So the first problem, we have 3 1/2 plus 2/3. So I'm going to multiply 2 times 3, which is 6, plus 1 is 7. So 3 1/2 is the same thing as 7 over that same denominator of 2, and I'm adding that with 2/3. Okay? Now remember, to add fractions, none of these rules have changed. It's just that we have to think about the setup of the problem a little closer first. So I need to make a common denominator. So I look at the multiples of 2 and 3 and know that they could both be multiplied by something to become the number 6. So with 3, I'd have to multiply by 2. So I'm going to do that in the numerator as well as the denominator, so I get 4 6. And with 2, I'd have to multiply by 3, so I'll do that in the numerator as well, and that will give me 21 6. So I add together the numerators, keep the same denominator. I get 25 6. I check to see if the fraction can be simplified, but it can't. So I'm okay with you guys leaving it in improper form. Now remember, if they did ask us to convert back to a mixed number, we would just take 25 and divide it by 6. So in problem number 6, I'm going to change the first mixed number right here, okay, into a single fraction by doing 4 times 5, which is 20, plus the 1 in the numerator would give me 21, and I'm going to keep it over that same denominator of 4. Now again, when I go to add the fractions, I know that I need common denominators. 2 and 4 both have 4 as a multiple. Since I didn't change this denominator of 4, I can keep the numerator the same also. Since this 2 changed into 4, I think about what multiplied times 2 to make 4, which was 2, and multiply the same value in the numerator, so I get 2/4. So this adds together to be 23/4. In the next problem, it's a subtraction problem, but really my focus here, we're doing all the things we've done before. Oh, sorry, guys, about the interruption. Okay, we're doing all the things we've done before. We just want to change this mixed number. So the 2 times 2 will be 4, plus the 1 will be 5. And again, we're going to put that over the 2 that has already been there. Then minus 1. Now, remember, a whole number, if I want it to look like a fraction, I put a 1 in the denominator. And now I'm going to work on making a common denominator. A 1 in the denominator, I can turn into any number I want by multiplying by that number. So I'm going to turn each of the denominators into a 2. For this first fraction, that means it's unchanged, so it's still going to be 5/2. And for this second one, it means I multiplied the 1 by 2, so I'm also going to multiply the 1 in the numerator times 2, and I get 2/2. So remember, we keep our denominator. We're subtracting here in the numerator, 5 minus 2, which is 3. So I have 3/2 as my answer. It doesn't simplify, so I'm going to leave it in that form. All right, the last problem, again, I want to rewrite both of these. So the 8, I'm going to think of as 8/1. And the 4 and 1/3, I'm going to convert to a single fraction. Remember, I know the denominator is going to be the same. And the numerator is going to depend on that process that we were just talking about. So 3 times 4 is 12, plus 1 is 13. So that's going to be 13/3. So again, I need to make a common denominator. And 1 I can turn into any number I want, so I'm going to choose it to be turned into 3, so they'll have the same denominator. So the 13/3 is going to stay because I didn't make any changes. But I did turn 1 into 3 by multiplying by 3. So I multiply by 3 in the numerator as well, and I get 24/3. Then I'm going to subtract in the numerator. So this leaves me with 11/3. And again, that can't be simplified, so that's going to be my final answer. All right, so to summarize what we were doing here, notice that every mixed number we turned into a single fraction by the process we talked about before. Okay? And that was this process of multiplying these two things together and then adding that extra part of 2. The denominator stayed the same, and your result after the multiplying and adding became the numerator. And then anything that was a whole number, we wrote as that whole number over 1 in the denominator, so that we could add and subtract even whole numbers, mixed numbers, anything by turning them into fractions. Okay? All right, so again, if you need the video pause to copy any of these problems down, ask politely for them to do so, and then we'll move on to the next set of problems. All right, so the last set of problems on the handout focus on multiplying and dividing. So what we're going to do is we're going to multiply and divide, but again, we want to turn everything into fractions before we do so. So in the first problem, number 9 on here, I see 2 1/3 times 4. So 2 1/3, again, the 3 times the 2 is going to be 6, plus the 1 is going to be 7. So I'm going to get 7 over 3. And then for 4 to turn it into the fraction, remember, I'm going to keep the 4 and put it over a denominator of 1. Since I'm multiplying, I do not need to make a common denominator. So I'm just going to go ahead and multiply across. So that will give me 28 in the numerator, and 3 times 1 will give me 3 in the denominator. Okay? So again, that can't be simplified, so I would keep it there. And then if I had to write it as a mixed number, I would go ahead and I would divide it out. So 3 goes into 28 9 times with a remainder of 1. So that means as a mixed number, this would look like 9 1/3. All right, for number 10, the 3 is our whole number. So I'm going to rewrite it as 3 over 1. I'm multiplying, and I'm multiplying with 1 1/2. So again, I'm going to do 2 times 1, which is going to be 2, plus the 1 in the numerator would be 3, and I keep my denominator of 2. And again, we multiply straight across, so we're going to get 9 in the numerator and 2 in the denominator. So our answer is 9 over 2, since that doesn't simplify. Or if we chose to write it as a mixed number, we would take 9 and divide it by 2. 2 goes into 9 8 times. Sorry, excuse me. Totally not paying attention. I was thinking about the answer. So 2 goes into 9 4 times. Hopefully you guys caught my mistake. Which gives a result of 8, and when we subtract, we get a remainder of 1. So 4 whole times with 1 left over out of 2. So our mixed number is 4 1/2. All right, the next problem is a division problem. And before I start the division process, again, I want to write everything as a fraction. So whole numbers, we're going to go over 1. And mixed numbers, I'm going to do the 4 times 1, which is 4, plus the 1 in the numerator, which gives me 5, and that stays over my denominator of 4. So 7 over 1 times the reciprocal of 5 over 4, which is 4 over 5, and I multiply across, so 28 in the numerator from 7 times 4, and 1 times 5 will give me 5. That can't reduce. So my answer is 28 over 5, and again, if I wanted to write this as a mixed number, I would divide 5 into 28. It goes in 5 times because 5 times 5 is 25. And it has a remainder of 3. So I have 5 and 3/5 if I chose to write it as a mixed number. And you should know how to do both, okay? We have learned how to convert fractions to mixed numbers. So the idea here, if you're given a problem with the mixed numbers, you change all the mixed numbers to fractions, you finish the operations, and then at the end, depending on what you're answering or what the question asks for, you'll either keep it as a simplified fraction or you'll write it again as a different mixed number. All right, so we have one more division problem to do with 2 mixed numbers. So this 2 1/8, we're going to do 8 times 2 is 16 plus 1 is 17, and that keeps 8 in the denominator. And then for 1 2/3, we're going to do 3 times 1 is 3, plus 2 is going to be 5, and keep the 3 in the denominator. Then remember to to divide fractions. We keep the first fraction, 17 over 8, and we multiply by the reciprocal of the second fraction. So 17 times 3, if I'm not sure, I'm going to write it out on my paper to make sure I get it right. So that's 51. So I'm going to get 51 over 8 times 5, which is 40. This doesn't reduce, so that would be my answer. And if I wanted to write it as a mixed number, I would take 51 and divide it by 40. 40 goes into 51 one time. 1 times 40 is 40, with 11 left over. So the mixed number that is equal to 51 over 40 as a fraction is 1 and 11 out of 40, okay? Or 11/40. Okay? So what you guys are going to do is you're going to use these examples to guide you. Okay? The handout on the other side is similar. The last thing we're going to do, since you're going to be using this as a guide for your homework, which you should complete in class today, is we're going to summarize what we did. So adding, subtracting, multiplying, or dividing problems with mixed numbers. So what we did each time is we would rewrite any whole numbers or mixed numbers as improper fractions. The improper fractions kind of get a bad rap because, believe it or not, they're actually the most useful form to add, subtract, multiply, or divide in. So the first thing we do is we write everything so that it's a single fraction, even though the mixed numbers and whole numbers would be improper fractions. The next thing we do is perform the operation. Okay, and what I mean by that is whichever operation you are directed to do. So if it's addition, you add fractions as you normally would. If it's subtraction, you subtract. Those require common denominators. If it's addition, or excuse me, if it's multiplication, you multiply. If it's division, you divide. And then at the end, we always work to simplify our answer if necessary. And we talked earlier about leaving it in a form. Now, the other side of the handout doesn't specify. So you guys are okay to leave your answers in improper fraction form. Tell you what, do all the problems on the other side of the handout, 1 through 12, and just leave your answers in improper fraction form. And then do what I did. For the last 4 problems, 9 through 12, also write those all as mixed numbers so you can make sure that you can do that well. Okay? So the remainder of the period is going to be spent working on those 12 problems. Okay? You need to work quietly. Okay, if you need help, ask for help. You need to work efficiently, and you need to work during the whole period. Okay? If you finish this, you can show the sub that you finished it, and then you can work on something else completely silently, but not until all 12 problems are done, they're correct, and the sub can check with the key, and that the last 4 problems, 9 through 12, have both an improper fraction answer and a mixed number answer. Okay? And I will see you guys on Friday.